So good morning, good afternoon, good evening, and welcome to ChaosConf. My name is Haytham. I'm the Global Chief Architect for the IBM Always On practice. And basically, my job is to help our large clients to think differently about availability, resiliency, and reliability. So we only have 20 minutes, and what I want to do today is actually give you a sneak peek into how IBM is modernizing mission-critical workload reliability and how chaos engineering plays a very important role to give us evidence and confidence that we're going to be able to meet our service level objectives and service level agreements. So a little bit of context first. IBM is 110 years old. We run and manage the backbone of the world economy, and that's not an understatement. We design, build, and manage 40,000 mission-critical workloads, right? That are handling billions and billions of financial transactions every single year. Now, of course, I don't need to tell you how critical those applications are, and most, if not exclusively, all of our clients are regulated. You know, it's a very tough environment to come and adopt new technologies, new resiliency practices, right? So we have to be very, very careful. Of course, this invites some challenges. You know, like I mentioned, most of our clients are regulated. That's true in transportation, financial services, retail, healthcare, so on and so forth, right? So change is not always easy, right? Even though most of our clients are transforming and modernizing, they're doing it in their own pace and by being a little bit more careful, right? One of the reasons why they're careful is because they have a lot of technical debt, right? Many of their applications have been built 20, 25 years ago. I mean, there is code that has been developed 20, 25 years ago, right? So, and nobody's maintaining them, right? There is also many applications that have been built by vendors that no longer exist, you know, and there was no investment or appetite to actually transform or to modernize those applications. You know, that's also it showcases, you know, challenges that we have when it comes to skills when we deal with our clients and an overall culture of change resistance. You know, many of them have been in their jobs for tens and tens of years. You know, it's not very easy to just come and say, guys, there is something called chaos engineering that you guys should do. You know, many of those applications run due to hope, you know, and hope is not a strategy, right? And the way we come and we try to change the mindset is by admitting that basically everything breaks, you know. This is an important message that our clients are accepting, you know, that everything breaks and that we should plan on it. You know, by planning, we'll be able to know how we're going to behave as an organization, how our ops, our SREs will behave, and even how the application will actually behave, right? Now, before talking about chaos engineering, you know, one of the aspects that we do as part of my work is to re-engineer or re-architect some of their applications to be resilient, to be reliable, you know, to achieve those 5 nines that they require. You know, so I always say that application must mitigate the 5 Fs. Your fires, your floods, your fools, and your fat fingers, you know. So very quickly, you know, your fires are your component failures. You know, this is when a VM fails, a switch, a router, a firewall, whatever, you know, even in like a library failure, you know, a JVM that those are your fires. Now, your floods are your physical failures mainly. You know, this is when your links, you have a regional failures, an entire data center that completely failed. You know, we call those floods. You know, so fires and floods, your component and your physical failures. Now, the fools and the fat fingers are very important because when we look at the majority of causes of outages in the world with our clients, infrastructure is rarely the cause. It's mainly software applications and humans. The human process. So the fools and the fat fingers. Your fools are what I refer to as sneaky SREs. These are your site reliability engineers that are not doing. They're not following the rules and not doing GitOps properly. They go to a prod, do some change, and that change caused an outage or a failure. So those are your fools. And finally, your fat fingers are your SREs that are not sneaky. They're following the rules very, very well, but for some reason, they launched a command line command and they fat fingered. They added an extra 0, or they had a syntax error, and which actually caused the entire control plane to fail. Right. So again, your fires, your floods, your fools, and your fat fingers. Okay, so of course this means that when we architect the application, when we re-engineer it, we have to take all of these F's into consideration, right? And how can we build a multi-active, multi-regional, multi-AZ environment that can that is decoupled really from I mean the application is decoupled from the underlying cloud and the underlying infrastructure, and that's what we do. Now, is this enough? Of course not. Again, hope is not a strategy, and we need to understand the behavior of our applications. And chaos engineering to us is something that we've been doing for a long, long time. It's very similar to site reliability engineering. We, IBM, used to do site reliability engineering for the past 20 years, but we didn't call it site reliability engineering. Even chaos engineering, IBM recently adopted the term chaos engineering. We used to call it failure-oriented testing. That's what we used to call it. And this is how we used to build our services. Of course, that was not in a cloud world. That was not in a cloud-native way. That's why we try to actually rely on what the industry, what everybody on the calls here built to actually and promote chaos engineering, and we build upon that two things. We built our own principles, IBM's principles of chaos engineering, and also IBM's methodology on applying or doing chaos engineering safely. So let's talk very quickly on the principles of chaos engineering, and I have to remind you that this is just a sneak peek. There's a lot of documentation attached to everything that I'm going to show you, but still, we felt it's important for you to understand or to know what IBM is actually doing in that space. So, of course, the first principle for us is to strengthen current or already in place, strengthen current reliability disciplines that are currently in place. It's not a good idea, or we don't think it's going to ever work if you don't have certain a foundation of business continuity and resiliency, and then you apply chaos engineering upon it. You have to have a baseline, to build upon. This awareness that resiliency is not a global thing anymore. Many clients, or the clients I work with, many think that resiliency is a global feature. An entire data center that that has a disaster recovery site. I do my storage-based data replication for everything. That doesn't work in a cloud world. That doesn't work in a cloud-native way, right? So, what we're trying to say here is that build upon current available reliability disciplines, right? Understand the system. Again, in the enterprise world, you have a lot of silo-based operation teams. The functional requirements are often the responsibility of the developers, and the non-functional requirements, such as availability and resiliency, are the responsibility of the ops or the SREs. That doesn't work anymore. Both teams have to come together, understand a business service. We use the term business service instead of a system or instead of application or infrastructure. A business service is built upon applications, middleware, brokers, Kafkas, storage, cloud, so on and so forth. Right. So understanding the critical path, the transactional critical path is very, very important, to understand flaws or to try to start to think of experimentations, where can I inject failures? Experiment on every component, it's not enough that infrastructure oriented ops do chaos engineering just by adding latency or removing a volume, that's on the infrastructure level. Yes, that helps. It's a great way to start, but we think that chaos engineering or failure injection should be done at the entire stack. We have to take our time to understand that transactional critical path and apply chaos engineering on every component when possible. Strive for production, regulated environments don't allow you to do just about anything, right? So we have to be very careful on how to promote chaos engineering in production. So this is why we use the terminology strive. It's good to start in dev, it's good to start in a contained environment, but we believe that chaos engineering has more value when it's done in production. So gradually apply it in production once you have more and more confidence. Contain the impact. Once you start to understand the system and you start to understand the critical path of your transactions, you can now figure out how to contain the impact, how to set proper fallbacks, how to set your own kill switches, so on and so forth, right? So that's very, very important. That's very similar to industry terminology, which is you have to minimize the blast radius, but for us, what our end users will see are a business impact. They're not going to see a blast radius. They're going to see a business impact. So measure, of course, learn, so observability, metrics, traceability. This is very, very important. And improve. It's all about improvement. It's all about going back to what we thought would happen. We thought how the application or the business service would behave, and proving or disproving that hypothesis. And when we understand the behavior, now it's time for us to improve. And that improvement can mean many things. It can mean that an SRE can do some things to enhance that certain fallback mechanism, or it could mean that we have to raise a new feature request or a bug against that application because it needs significant development, right? So measure, learn, and improve. Increase complexity gradually, very similar to contain the impact, except that in real life, you're going to have multiple failures that happen at the same time, right? And if the architecture of the application and the entire business service is properly engineered, if multiple failures happen at the same time, you should be okay, right? So this is what we're trying to say. No, try to gradually increase the complexity of your failures. An example of doing this is actually doing multiple failures at the same time. That's not a bad idea. Do we do it in the beginning? Of course not. But as you gain more and more confidence, do that. It's very important. Finally, and this is one of the most important things, is to actually socialize. You need to socialize chaos engineering. You need to socialize failure-oriented testing. By conveying the message that by balancing short-term risks for longer-term reliability, you might get more advocation. You're going to advocate chaos engineering. You're going to get more support from your management. So, and that's for us. That's very, very important. Again, in a regulated industry, socializing chaos engineering is very important. What are the benefits? What the value? What are the risks? These are things that our clients really need to be aware of, and they appreciate that we are very open when we talk about chaos engineering. So, of course, this is just a sneak peek. We have a lot of documentation to explain every single one of those principles. But let me now. Now that we talked about the what, let's talk about the how. How do we start, and how do our organization do chaos engineering? Especially when we talk about mission critical workloads. And this is why we built our own methodology. We have IBM is a large consultancy. We have methodologies, and we just build one specifically to tackle reliability and resiliency. So here's also a sneak peek into IBM's chaos engineering methodology. So first of all, it's made out of 10 major points. Every point has a lot of activities that need to be done, right? So like I said, understand the system, So once you are convinced and once you have the buy-in from the organization that you need to do chaos engineering, and sometimes you need to understand the system to identify flaws and issues before you come and you get organizational agreement, right? So understanding the system end to end, that also means understanding previous outages, postmortems, the transactional critical path that we discussed earlier, so on and so forth, right? That's going to make you more aware of, okay, where to start, if I think that a certain fallback mechanism is not working, let me start there, right? Gain organizational agreement. That can come before or it can come after. Once you understand that, or once you are convinced that a certain flaw exists in your system, you need, and you want to prove or disprove it using chaos engineering, you must gain organizational agreement. Everybody must be aware what you are going to do, what are the risks, what are the benefits. Of course, by socializing, it will help you a lot. Create a hypothesis, plan the experiments. I'm pretty sure now that you are ChaosConf, you know what this is all about. We call them experiments instead of failure injections or attacks. It's an experiment, and it will be proven or disproven. Okay, so, and that's can only come after we understand the system very well. Now, observability is a very important topic. How can I measure, how can I understand the behavior of my application as I experiment on it, right? So I need to make sure that I have the right observability tools in place, right? Prepare your experiments. That can mean many things. If you're starting with a small team, you don't need to do game days. You don't need to, if you do it on dev or on a UAT environment, you can escape being strict, but as you move to production, you need to plan your experiment very well. That means that you have to bring every stakeholder and make them know what they're supposed to do. Who's the chaos commander? Who's the person with the authority to just apply the kill switch or to roll back the entire experiment. And then, of course, you need to run that chaos experiment after you created your hypothesis, you enabled observability, and prepare experiment, of course, is also scripting whatever injection you want to do. That's also part of the preparing the experiment. And running the chaos experiment is actually any script or any tool you use to do chaos engineering is to actually submit that experiment. Now, once your experiment is actually running, hopefully it was contained the right way and you didn't have a impact on the business. It's time for you to analyze the result and to see if you have proven or disproven your hypothesis. Are your fallback mechanisms in place? Are your reliability components, your circuit breakers, your load balancers, your global traffic managers, are they all working the right way? Your retries, so on and so forth, right? Even if you prove or disprove, you need to communicate your findings, because I'm pretty sure, we all know that you're going to find some very interesting results, and those results are things that you, as an SRE, as a chaos engineer, can fix by yourself, or you can have to raise a service request or a bug request or a feature request, against the development team, or so on and so forth, right? So here we're saying that you need to communicate your findings, bring all of the stakeholders in one place, and improve. Grow your blast radius and repeat, right? That's not we all know this, and this is very important. You have to start small and grow your blast radius. That means you must touch other dependencies, you must attack other dependencies, and try at the end to really, because you're dealing with business services that are mission critical, you have to enlarge the surface of your experiments. And finally, expand into production. That's very, very important because, like I said, there is no value there is value, but the value and the benefits to chaos engineering happen only when you really expand and you slowly and gradually expand to production. But when you do this, you're gonna have to start everything over again. So with that, I hope that I was able to give you in only 20 minutes a short sneak peek on what we're trying to do and what we're doing with our most mission critical workloads. I invite you all to visit some links, ibm.biz/meetchaos,